So here we are dealing with basically numbers. We all know that every number is in one or other sense they are different. We have seen a lot of numbers starting from our lower classes. We have seen natural numbers, integers, rationals and so on. So here basically I am discussing with properties of natural numbers. So I am basically interested in every positive integer. Now yeah, I am classifying these numbers into certain parts, because if I choose some number, for example if I choose 5, we know that 5 in some sense 5 is an odd number. Also I'm interested in finding the factors of 5. So the only divisors of 5 we know they are just 1 and 5, and we call such numbers as prime numbers. Of course we have a lot of prime numbers starting from 2, 3, 5, 7, so on and so forth. So here we are seeing what is the definition of factors, and we will see what are perfect factors and so on, partner factors, so on. So first let us see what's the definition of a factor. A factor of a number is an exact divisor of that number. That means if I pick some number, if I pick 4, I have exactly how many factors? Yeah, I have 3 factors. I have 1, 2 and 4. Similarly, if I go for 6, I have exactly 1. 1 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6 and 6 is a factor of 6. So we have 6 factors. So similarly, we can see the examples. For example, we have, if we pick a number called 12, 12 have 1, 2, 3, 4, 6, 12. These are the factors. We call them divisors too. Now if we pick number 8, we have 1, 2, 4, 8. So these are other factors. Now what is the definition of a factor? If we divide this number, if we divide 12 with 2, there will be no remainder. The remainder part, that will be equal to 0. Similarly, if you divide 6 with 12, we have remainder 0. If you divide 12 with 12, we have remainder 0. So that is the definition. That is another kind of definition for them. If we divide a number with that particular number, and if the remainder that is equal to 0, we can say that it's a factor of that number. Now we can see what's the definition of a partner factor. If I pick a number, for example 24, and what are the factors of 24? 1, 2, 3, 6, 8, 12 and 24. These are the factors. And among this, if I multiply 12 with 2, we have 24. If I multiply 8 with 3, we have 24. If I multiply 6 with 4, we have 24. So the definition of a partner factor, it is nothing but product of two factors of a particular number is that number itself. That means if I multiplied 1 with 24, we have 24. So 1 and 24 are partner factors. Similarly, if I multiplied 2 with 12, we have 24. And if I multiply 6 with 4, we have 24. 8 with 3, we have 24. So these are the definition of partner factors. Similarly, we can see, is 12 multiplied with 8 a partner factor, or 12 comma 8? No. 12 and 8 are obviously they are factors, but if we multiply 12 with 8, it's not equal to 24, so it's not a partner factor. Now we can go for next one. We can see the definition of perfect square. I can say 1, 4, 9, 16, 25, so on, 36, 49, so on. These numbers are all perfect squares because there exist certain natural numbers such that the square of that natural number is equal to this number. So by definition, because there exists such an n such that n is equal to some m square. Okay. Now we can see 1 square, it is 1. 2 square, that is 4. 3 square, that is 9. So find the perfect square numbers. What are perfect square numbers? Find the perfect square numbers between 40 and 50. We can just take it as an example. Find a perfect square number between 40 and 50. Does there exist a perfect square number between 40 and 50? We know that between 40 and 50 we have 49. 49 and 49 is nothing but the square of 7. 7 square is the 49. 7 square is equal to 49. So 7 is a square number. So 49. Okay. Next one we have 60 and 70. In between 60 and 70, we can choose a number 64. 64 which is equal to 8 square. So there exists a perfect square which is equal to 64, which is equal to 8 square, which is equal to 64. Now we can study about detail about square numbers. So can a square number end with digits 1, 2, 3, 4, 5, 6, 7, 8, 9? So let us see basically. it's a detailed topic. We know that. So these are the squares which we know. 1 square is 1, 2 square is 4, and 3 square is 9, 4 square is 16, 5 square is 25. Here you can see that 4 square, the square of 4 which in the units place, that is 6. 5 square, the units place will occupy, 5 will occupy the units place. Here it is 6, the square of that number units place will occupy with 6. Similarly 7 units place will occupy by 9. Here we have 8 square which will be covered by 4. 9 we have 1, and 0 square, that is always 0. So you can see basically the unit digits will occupy by certain numbers. We have 1 is a possibility, 4 will be there, 9 is there, 6 is there, 5 is there, 6 is there, again 9 is there, 4 is there, 1 is there, 0 is there. And you can see we do not have a units place, we cannot fill with 2, 3, 7 and 8. In units place, we cannot see 2, 3, 7 and 8. They are empty in that space. So if it's easy for us to determine whether a number is square number, we can assume, at least we can say whether it's a square number or not by looking at its unit. We may not be able to say exactly whether it's a square number or not, but at least we can make a conjecture. So we can see. On observation, square numbers never end with digits 2, 3, 7, 8. Okay, so it's an observation from this. Now let us see. For example, 1, 9, 2, 3, 8 is not a perfect square. Why? Because its units digits end with 8. We know that if a number that particularly end with 8, it will not be a perfect square. We can go for next one. 1, 3, 7, 9, 7 is not a perfect square. Why? Because its units digit is occupied by 7. If a number which ends with 7, it's also not a perfect square. If a number has 1 or 9 units place, then its square ends with 1. Okay. That means if I pick some numbers, let us see some example. 11. In the case of 11, it's end with 1 in its units place. So what is 11 square? It is 121, in which it's end with 1 at its units place. Similarly, let us go for next one. 19. 19 square, which is equal to 361. So if it is 9 and 11, the unit place will always end with 1. 29. 29 square, which is equal to 841. So its units place also ends with 1. Next one, number of zeros at the end determine whether it's a perfect square or not. Okay, if the number of zeros is even, it can be a perfect square, and if the number of zeros is odd, it's never a perfect square. So 40, it's not a perfect square because the number of zeros is 1. It's an odd number and it's not a perfect square. Similarly, 400, it's a perfect square. 400 is a perfect square. One of the reason is it has 2 even number of zeros, because it's 2 zeros, so it's an even number. But say contradiction to our assumption, because 200 it's not a perfect square, since even though it have 2 zeros as even numbers, even though it have 2 zeros at its end, it's not a perfect square. Now 300, it's not a perfect square. 1000, it's not a perfect square since it have 3 zeros. The number of zeros for 900, which is 2, and it is a perfect square. So we can study detail about these things. So conclusion, we have, if a number of zeros is odd, it's never a perfect square. And if the number of zeros is even, it may or may not be a perfect square, because we have already seen 400 is a perfect square and it satisfies the condition the number of zeros is odd, but still it's a perfect square. And you can see whether we pick for 700 or 200, they are not perfect square even though it have even number of zeros. Next, we can see the only possibilities at the units place for a square number, they are 1, 4, 9, 6 and 5, 0. So the square of an even number, that's always even. If I square some even number, that's always even, and if I square an odd number, that's always odd. So that's a conjecture for us. Find which among our perfect squares. Is 7, 2, 8 a perfect square? We know it's a big no. Why? Because its units digit end at 8. If a number which ends with 8, it's never a perfect square. So similarly, you can see here 8, 7, 6 and we have 3 zeros. Since the number of zeros here it is odd, it's also not a perfect square. So this is also never a perfect square. Now 1156 can be a perfect square since it ends with digit 6. We can see this one. 1156, this is a number, just a number 1156. It can be a perfect square. Why? Because it ends with digit 0. We cannot say it's a perfect square. But so far we can say it can be. There is a possibility for him to be a perfect square. So for that, we know that 1156, it somewhere lies between, what is the square of 30? It is 900. So, and what's the square of 35? We know that is 1225. So, 1156 lies between 900 and 1225. And we know that the last digit, that is 6. So, for finding whether which of the numbers satisfies this criteria, it's a number between 30 and 35. So, can 31, if I pick 31, the last digit is 1. So, 1 square, that is 1. So, its units digit must be equal to 1. So, here it is 6. Now, if I go for next one, I go and pick for 2, 2 square, that is 4, 32. Okay, 32, its units place is 2, and if I go for the squaring part, I have 2 square, which is 4. So, 4, here we have 6. And next I go for 33. 33, we have 3, 3 square, which is 9. And next I go for 34. 34 can be, that's a possibility for 34, because 34, 4 square, that is 16. Here also units digit is occupied with 6. Now you can check for whether 34 is a possibility. So 34 multiply with 34, which is equal to 1156. So 1156 is a perfect square, and that square root is equal to 34. Now next one, what will be the unit digit of the following squares? 17. We know that 17, we need to find the units position. So units digit. So 17, here we have, what is 7 square? 7 square is 49, and the unit digits of 17, that is 7, that is 49, and the unit digit must be equal to 9. So we have that is equal to 9. Here 4, 3, 2, 1, the units digit, that is 1. So 1 square, that is equal to 1. Similarly, here we have 197347 Here the last digit, that is 3, 3 square, which is equal to 9. Which of the following numbers will have even squares? Even square number. So here you, while looking, you can see that 23413, it's an odd number. Here this is an even number. Here 43114, that's also an odd number. So we know the square of an odd number is always odd, and the square of an even number is always even. So we have, this is not as odd square, even number, so it must be odd number. Here this is an even number, so we have, it's an even number. This is an odd number, so it's not even. It's not because it is odd. Here also it is not because it is odd. Now these are the patterns of numbers, because as a number theorist we are always interested in finding patterns. You can see that these are called, first one, they are called triangular numbers. The number of points that we require to construct a triangle. Here you can see, starting from 1, here I have 3, here I have 1, 2, 3, 4, 5, 6. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. So these numbers, they are called triangular numbers. But basically in this chapter we are not interested in triangular numbers or pentagonal numbers. We are basically interested in square numbers, because we are seeing squares. So in some sense a square is nothing but the number of points required to construct a square. You can give a definition that too. Here you can see, here I have 1, here I have 4, here will be 9, here there are 16, and next it will be 25, so on and so forth. So that is also a definition of a square number. And these one, they are called pentagonal numbers, number of points required to construct a pentagon. And we have a lot of numbers, because we are always interested in finding patterns. And in this chapter we will be basically dealing with square numbers starting from 1, 4, 9, 25, so on.